Hello. For our AERO 320 project, we'll be talking about something aerospace people find very interesting: autopilot. If for some reason you find yourself watching this video and don't know what autopilot is, it's a flight control system that allows a pilot to fly an airplane without continuous hands-on control of the aircraft. This allows the pilot to focus on other important tasks such as navigating, communicating, or planning for inclement weather. This is a common feature in many aircraft, but can have varying degrees of complexity. Simple autopilots can hold one axis of control, while more complex systems can control 2 to 3 axes or even navigate and maintain a GPS course. Autopilot systems are responsible for taking information from sensors about the aircraft's flight dynamics and changing the required control surfaces to correct for any deviations from a desired input. A simple example of this about one axis of rotation would be changes in elevator pitch to control altitude. The pilot can set a desired altitude into the autopilot, and from there, information about the aircraft's instantaneous altitude and vertical speed is pulled from the corresponding sensors and used to calculate the required elevator deflection angle to get to and hold the desired altitude. This can also be applied to hold a specific heading using aileron and rudder deflection, but for the remainder of this video, we'll focus on the single axis case, holding altitude with elevator pitch.
The governing equations for the aircraft dynamics and stability are similar to those of other dynamic systems. They include the energy equation, which accounts for speed and altitude fluctuations in its kinetic and potential energy terms, as well as velocity and acceleration equations. We should also look at the weight and lift equation for an aircraft as well, as it comes into play in the potential and kinetic energies. And we can combine all of these together and derive the equations of motion of the aircraft. This gives us an accurate representation of what the onboard autopilot is doing to maintain altitude. It will detect small differences when at altitudes higher or lower than desired, then calculate and execute the required control surface deflection to bring the aircraft back to the set altitude. This can result in what is referred to as phugoid oscillation, which is where an object cycles between states of high potential energy and high kinetic energy, but the time average between these states remains relatively constant.
Automatic flight control systems commonly utilize a negative feedback loop. This feedback loop is essentially as follows. The pilot sets a control mode to maintain altitude. Changes are detected by the altimeter, vertical speed indicator, and other sensors on board the aircraft. This information is pulled from the sensor to the autopilot computer. Then the computer calculates the error associated between the instantaneous altitude and the desired altitude, as well as the rate this error changes, the derivative of the error, and whether the total error is increasing or decreasing, the integral of the error. The autopilot computer then signals the control surface servo, in this case the elevator servo, telling it to make a very precise adjustment. Servo movement mechanically moves the physical control surface, causing the deflection. The autopilot computer then pulls new information, recalculates the error, and sends another signal with another precise adjustment to again reduce the error in altitude. This is considered a negative loop because the output of the system is fed back into the dynamic process in a manner that reduces fluctuations in future outputs, promoting a more stable set of outputs. Also, this is all done continuously, allowing the plane to hold the altitude, granting the pilot hands-free control of the aircraft.
Shown here is a block diagram that represents the control thought process of the autopilot system. It takes in inputs of the current altitude from the altitude sensors and the desired altitude, as well as vertical velocity information. All of that is processed together through a PID controller, and then the vertical velocity data is added to account for the rate of change. Now, this all enters a limiting angle of attack function that ensures that the aircraft will not increase its angle of attack to be on stall to keep everyone safe on board, and ultimately outputs a pitch command for the elevators to control the aircraft and get it back to the desired altitude.
To summarize, Autopilot is a continuous dynamic system that takes in information from the aircraft sensors, calculates errors based on desired inputs, then calculates and executes a servo change which causes a deflection in the corresponding control surface of the aircraft. This is all done in the form of a negative feedback loop utilizing a PID or proportional integral derivative controller type system.